Okay, I'm going to go over the answers to your assessment here. Okay, most of this question was pretty straightforward, so I'm going to go through this one quite quickly. So for the median and interquartile range, you've got 99 objects as is indicated here. And what we want to do is find a median, so we want to find the 99 plus 1 divided by 2, the 50th place. So you do a running total, 14 at 35 at 25 and so on and so on. And the 50th ends up being in this category here, because 14 at 35 is 49, so the 50th person is going to be in the next category. So the median is 3. For the interquartile range, we need the upper quartile and the lower quartile. So the way I always think about it is the upper quartile and the lower quartile. Well, that's the median of the first half. So you can call that, I mean, you could do this by estimate because it's grouped. So it's about the 25th. So that's clearly going to be 2. The median of the upper quartile is going to be the 75th. Well, 35 or 25, that's 60. Add 14, 74. So the 75th or the 75.5, either way, it's going to be 4. So the interquartile range is going to be 4, subtract 2, which is 2. Mean and standard deviation. I will be making another video soon about complete use of your calculator, but I've done one previously, and the mark scheme they accepted any answer between 1.68 and 1.69, and that's just using your calculator effectively. So okay, part B, you're now told that there's 163 households surveyed, of which 64 contain no houses. So those 64, so you imagine putting another column here where 0 and a 64 say. The new mean, well, if you take your old mean and multiply it by 99, so whatever answer was here, so let's say if it was 1.68, times that by 99 and you'll have the total number of children. Then you add 0 to it because you got 64 lots of 0, but you divide by 163. So basically it's the old total divided by 163, whereas this number was the old total divided by 99. Say whether the standard deviation will be higher and so on and so on. Well, it will be higher, it will be increased, and it doesn't ask you for the reasons, that's just a 1 mark, but the reason is you got a greater spread. Okay, 0 is an extreme, the lowest value you can have, the most extreme value you can have, and that's going to increase the spread of the data. And if we come to this one, where quite a few of you struggled, so let's talk about this one in some detail. It is claimed that for all 163 households on the estate, the number of children per household may be modelled by approximately a normal distribution. Comment to justification of this claim. Your comment should refer to a fact other than the discrete nature. Now this is one of the sneaky ways they test this knowledge, that for a normal distribution, most of the data is within 2 or 3, doesn't matter which number you use, standard deviations of the mean. Now the standard deviation, which I didn't mention here, was the accepted answer between 1.3 and 1.32. So let's say I take the 1.3 figure. Well, your mean's 1.68. If you subtract 2 lots of 1.3, that number's less than 0. And this is the kind of calculation you have to show, because in this context, the number of children, you can't have a negative number. That is why the normal distribution is not an appropriate model, and you have to say that in words. So if we were to write the answer clearly, we could say 1.68 take away 2 times 1.3 is less than 0, hence the normal distribution is not an appropriate model. But without the explanation, you didn't get any marks for just saying it's not an appropriate model. It was dependent. So we're going to question 2 next. Okay, so now we're looking at the next question, question 2, and you can see it's a normal distribution question. So hopefully you found this one straightforward. The first few parts are literally just using your tables and so on. Now, first part, some of you got wrong. any equals to is equal to 0 because it's a continuous distribution. Simple mark there. For part 2, you need to standardize your 425. So do 425. Remember, label your question. So that's your sigma. So 425 minus 421 all over 2.5. You get an answer there. I'll just quickly work it out. Of 8/5, which is 1.6. That's a positive answer, so you want probability that z is less than 1.6. Just look that up on your tables and you then put an answer. I can tell you now that in the mark scheme they accepted an answer anywhere from 0.945 to 0.946. If you use your tables you get the most accurate answer, but it will be in that range. And for part 3, the way you do questions like this, remember you do the upper bound minus the lower bound, and then standardize both your numbers. So for the 424, do 424 minus 421 over 2.5 minus 421 divided 2.5, that's 1.2. And if you do this one, you get 418 minus 421 over 2.5, and if you do any calculation, you might notice that the difference is 3 but the other way, so it's going to be minus 1.2. So altogether this is going to be the probability that z is less than 1.2 minus the probability that z is less than minus 1.2. This one you can look up in the tables here. This one is 1 minus the probability that z is, so if you do a quick diagram, being less than minus 1.2 is the same as being more than positive 1.2. So that's 1 minus probability that z is less than positive 1.2. And so you've only got to look up the 1.2 value. If you do that and you subtract them in this way, again the mark scheme accepts any answers between 0.769 to 0.770. And so part A should have been relatively straightforward from that point of view. For part B, determine the value of x. So part B and C are a little bit more complicated. So determine the value of x such that the probability of x is lesser than small x is 0.98. So sketch this out. Let's do a quick sketch. You want to find a value for x such that this area is 0.98. So we'll look up our inverse tables. If you look up your inverse tables, in the mark scheme they gave a mark for looking up any number between 2.05 and 2.06 for z. And then once you have your value for z, we work backwards. So once you work out your value for z from the tables, you plug that value into here. Mu's 421, sigma's 2.5. Plug your value of z into here from your table and rearrange that for x. And in the mark scheme they gave marks for any answer from 426 to 426.3. Last of all, part C. Let's drag this down a little bit. For part C, determine the weight. So the weight y grams, the variables change. We model by a normal distribution of a mean, and standard deviation of 3. Find the value of mu such that this is true. So again, sketch it. 410 is here, and you want this area to be 0.1. Now, that's less than the mean, so this the z value that goes with 410 is negative, so let's look at the opposite. There's going to be a negative z value there. The positive version of that z value would have 0.1 over here and 0.99 over here. So we look up 0.99, and again, they give you marks for picking any z value between minus 2.33 to minus 2.32. Take that z value, make it equal to x, which is 410, minus the mean over the standard deviation, and rearrange for the mean. And you should get an answer of exactly 417 if you do that. So hopefully you understand. I mean, you can go through these accurately with the correct calculations, but I'm just quickly going over the methods here. Okay, so question 3 now. This is all about the binomial distribution. What we'll do is read the question very carefully. So you're looking at an analysis of the number of vehicles registered by each household within a city. So here you got 18% of households have no vehicles registered, 47 have one, and so on and so on. A random sample of 30, so there's your n. Within the city selected, use a binomial distribution, and even say n is 30, together with the relevant information to answer the following. So exactly 3 households with no registered vehicles. So A part 1, no registered vehicles means we're looking at 18% of them, so that's your probability, 0.18. And we want no registered vehicles, 3 of them exactly out of the 30, so that's 30 C3 times 0.18 to the power 3 times 1 minus 0.18 to the power 30 take away 3. And so if you do that in the mark scheme, we accept any answer from 0.111 to 0.112. That's 3 marks there. Part 2. At most 5 households with 3 or more registered vehicles. So the probability of being 3 or more is this 0.1. You want the probability that x is at most 5, which means it's 5 or less. So you look up that, go to your tables, n's 30, p's 0.1, and look up the number for 5, and it gives you the answer marks for anything between these two values. Part 3, more than 10 with at least 2, so at least 2, now that means 2, 3 or more, so you're going to add up your 25 and your 10, so p is 0.35, at least 10 means x is more than or equal to 10, which is 1 minus the probability that, it says more than 10, beg your pardon, so that's strictly greater than 10, and that's 1 minus the probability that x is less than or equal to 10, because you want 11, 12, dot, 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 so take off all the numbers, 0 to 10. You look up that number after tables, and the accepted answers, an answer of 0.492 for that. And part 4, exactly 2 registered vehicles, so that's the 0.25 figure, and you want fewer than 10 but more than 5. More than 5 but fewer than 10. So all you do here is just write down the numbers you want. So at more than 5, so that's 6, 7, 8, 9, but fewer than 10, so I'll stop at 9. So I'll do this one as probability that x is less than or equal to 9 minus the probability that x is less than or equal to 5. Look up these numbers and subtract them, and you should get an answer somewhere between, the mark scheme accepts answers between these two numbers. And part B, again just a bit of theory. For a random sample of 150, so there's your n, we select to estimate the mean and variance of the number of households in the sample that would have either 1 or 2. 1 or 2, so that's 0.18 and 0.47. So that gives you a probability of 0.65. N's 150, so the mean equals NP, 0.65 times 150. Oh, sorry, not 0.65. That was I should be adding 47 and 25. So P's 47 add 25 because I looked at the note by mistake. So sorry, P's 0.72. So if we do that instead, we should have the correct answer, which is 108. And then for variance, variance is NPQ, so that's 0.72 times 150, so that's your P, that's your N, your Q is 1 minus that, which would be 0.18. Beg your pardon, 0.28 even. And that gives you answer 30.24. Okay, we're looking at question 4 here then. So as you can see, I've gone through all these words, a very wordy question, and highlighted the parts of statistics, so mu, sigma, n, and it's obviously about a sample because look at the mean length in a pack. So we want the mean length in a pack. So if we look at this one, the probability that x bar is less than 1 meter. So because we're looking at the sample mean distribution, when we come to standardize, we take it away from the mean. Now, 1 meter, simple thing, is 1,000 millimeters, 100 centimeters, and then times 10 to 20 millimeters, minus the mean, all over. Now, here's where a lot of you lost some marks. It's over the standard error. It's over 15 over root 12 because, as previously stated, it's a sample. So there's lots of method marks for realizing that that's what you should do. And once you do that, do the probability that z is less than that. So if I quickly work that out, that's minus 5 divided by 15 over root 12. Okay, so that's minus 1.15, I make it. And obviously this is a negative, so this is to the left of a negative, which is going to be the same as to the right of the positive. So that's going to be 1 minus probability z is less than positive 1.15. And if you do all that, you should get an answer, and I'll accept answers between 1.23 and the mark scheme to 0.126. So a bit of an error bound there. Right, part B. So this time, they put it in bold. We're talking about the thickness now. So here you should have noticed that the first part was talking about the lengths of the galvanized steel. Here we're talking about the thickness. This time there's 24, so n's 24. And you're told that the mean of this sample is 4.65. We're given the same standard deviation, 0.15, and 99% confidence interval. So you should know a standard formula which looks like this. Okay, so we've got to put the numbers into this. So x bar is 4.65, sigma is 15, n is 24, and now the z value is the important part. Obviously you've got to look this up in your formula booklet. For 99% you look up 99.5 and you should get 2.5758, and obviously there's marks for this correct number here. You do all that and the mark scheme accepts an interval between 4.57 and 4.73. But this is something you should learn and know how to use. So that's part 1. And part 2, comment on the claim that the mean thickness of such straps is greater than 4.5. Well, the main thing to notice is that the lower class bound is more than 4.5. So the way I'd say it would be 4.5 millimeters is less than the lower bound of the class interval. Hence, evidence, I always use this phrase, evidence suggests, claim true. And this should be a relatively easy question in the exam. And most of you did do well on that. That's 10 easy marks right there. Okay, and if we go to the very last question then, let's copy and paste this in. This one, more people struggled with, in fact, than the others. So I'm just going to screenshot this in. Okay, so there's not too much calculation in this one. This one's more understanding. This is the one I think needs the most work on. Do this in red. So you're given a table of data about 645, and that's the total MPs, the gender, and the parties that are in. So A, one MP was selected at random for an interview. Calculate 3 decimal places. So whenever you see an instruction, highlight it. The probability that MP was, and if we look at this now, a male conservative, so you're 175 out of 645. So that's going to be 175 out of 645, and remember you got to go to 3dp, so that's 0.271. A part 1 that was. This is going to be A part 2. Next one, a male. So the total males is 519, so that's 519 out of the total. 0.805. Part 3, a Liberal Democrat, and there's 63 of those out of 645, so that's going to be quite a small number. 0.098. Right, part 4, given that question. So remember, given that questions are probability of A given B, so probability of A and B over the probability of the second condition, the given that part. So here, A and B is labour and female. So labour and female is 94 over the given that. So over given that female, so the total number of females is 126. And that's 0.746. And part 5, male and not labour. So male and not labour, well, male and not labour is, I'll do this and say green or blue. So let's do this one in blue. Male and not labour is that, that, and that, or 519 minus 255, whichever way you want to do it. So that's 264, male and not labour, out of, it's given that, not labour. So not labour is that, add that, or 645 minus 349, 296. So 264 divide 296 is 0.891. So though some of you struggle on the given that's, but it is a straightforward method that you should have learned, this thing here. Right, let's go on to part B and C to finish off then. So for part B, 2 female MPs were selected at random. Calculate the 3 decimal place probability that both MPs were Labour. So we're only selecting females, so the total is out of 126. But after you selected one, there's only going to be 125 left. And the probability of selecting 2 Labour is 94, because there's 94 Labour female MPs, and then if you already selected one, there's only 93 left. So that's 94 times 93, divide 26 times 125, 0.555. And last of all, and this usually is the trickiest question, I'll do it in green. 3 MPs are selected at random. Calculate the 3 decimal places, the probability that exactly 1 was Labour, 1 was Conservative, and so the other one can be the other or the Liberal Democrats. So again, we need this trick where you reduce the total by 1 each time. So the total is 645, so that's going to drop by 1 each time as we select one person. Let's say we take the Labour one first. Well, there's 94 Labour to choose from. Oh, beg your pardon, that was just females. There are 349 Labour to choose from. Conservatives, there's 193 of those. But the other one, you don't want to be Conservative or Labour, so there's 63 at 40, 103 of those. You're going to do this, but here I've done select a Labour, then a Conservative, then not either. But that could happen in different orders. And if there's 3 objects, the number of orders I could do this is 3. So if you just think about the place where you select this person, there's 3 different places that could go. So, and if you do all of that, you got 349 over 645 times 193 over 644 times 103 103 over 643, 6, because there are 6 different ways you can order 3 things, That's, I mean, you can think of it like this. If you had numbers 1, 2, 3, how many ways can I order those numbers uniquely? Or you say there's 3 choices for the first one, 2 choices for the second place once you made the first choice, and 1 choice for the third place. Different ways you can think about it, but it is a times 6.